is how those encourage or can encourage accelerated fat loss, because it turns out they can. Remember, your nervous system, which includes your brain and your spinal cord and all the connections that they make with the organs of the body, governs everything. The nervous system and the role of the brain and other neurons has been vastly overlooked in the discussion about losing fat. Now, I would be remiss, and I'd probably come under a pretty considerable attack if I didn't just acknowledge up front a core truth of metabolic science and also of neuroscience, frankly, which is that calories in versus calories out, meaning how many calories you ingest versus how many calories you burn, is the fundamental and most important formula in this business of fat loss and weight management in general. There's simply no way around the fact that if you ingest far more calories than you burn, you're likely to gain weight. And a good portion of that weight is likely to be adipose tissue, fat. It's also true that if you ingest fewer calories than you burn, that you will lose weight, and that a significant portion of that will come from body fat. What portion depends on a number of factors, but that simple formula is important. So a calorie is a calorie as a unit of energy, and we need to accept and acknowledge this calories in, meaning calories ingested versus calories burned formula, but the calories burned portion is strongly influenced by a number of things that you can control that can greatly accelerate or increase the amount of adipose tissue or the proportion of adipose tissue that you burn in response to exercise and food. Today, we're going to talk about the fact that your body fat of various kinds, and there are several kinds of body fat, are actually innervated by neurons. Neurons connect to your body fat and can change the probability that that body fat will be burned or not. So your nervous system is the master controller of this process, and it plays a strong role in the calories out, the calories burned component. So let's talk about fat utilization. Let's talk about how fat is converted into energy, which is sometimes also called fat burning. There's two parts to this process. One is fat mobilization, and the second is fat oxidation or utilization. And that's a process called lipolysis. Fat cells can be visceral around our viscera, our organs, or they can be subcutaneous under our skin. Stored fat has two parts that are relevant here. It's got the fatty acid part, and that's the part that your body can use. And that's attached to something called glycerol, and they're linked by a backbone. To mobilize fat, you got to break the backbone between glycerol and these fatty acids, okay? That's accomplished by an enzyme called lipase, but you can forget all that if you want. Remember, we're just trying to mobilize fat. So the first step is to get those fatty acids moving around in the bloodstream, to get them out of those fat cells. And then they can travel and be used for energy. They're going to go into cells that can use them for energy. And once they are inside those cells, they're still not burned up. You need to oxidize them. They need to be moved into the mitochondria. And then they can be converted into ATP, into energy. So just to really zoom out again to make sure I don't lose anybody, you got to mobilize the fat, then you have to oxidize the fat. And many of the things that the nervous system can do is to increase the mobilization of fat, but also the oxidation of fat. So what are these neurons that connect to fat doing? What are they releasing exactly? How do they actually increase fat mobilization, and how do they increase fat oxidation, burning of fat? Well, there are a couple of things that they release that encourage that process. And the main one that you need to know about is epinephrine or adrenaline. The conversion of these fatty acids into ATP in the mitochondria of cells is favored by adrenaline. Okay? And adrenaline is released from two sources. Adrenaline is released from the adrenal glands, which sit atop our kidneys in our lower back. And it's also released from the so-called sympathetic nervous system, although that name is a bit of a misnomer because it has nothing to do with sympathy. It has to do with stimulating alertness and promoting action of the body. It was thought for a long time that adrenaline swimming around in your body of when you're fasted, because fasting can increase adrenaline, or when you're engaging in intense exercise, or when you're stressed, is going to promote fat oxidation. That's actually not the case. The adrenaline that stimulates fat oxidation, the burning of fat, is coming from neurons that actually connect to the fat. It's a local process. And this is very important because it means that what you do, the specific patterns of movements, and the specific environment you create that can stimulate these particular neurons to activate fat, meaning to release fat, to mobilize it, and then to burn it, is going to be a powerful lever that you can use in order to increase fat loss. Okay, so let's talk about how to activate the nervous system in ways that it promotes more liberation, movement, mobilization of fat, and more oxidation of fat. So one of the most powerful ways to stimulate epinephrine, which is also called adrenaline, from these neurons is through movement. The type of movement that I'm referring to is extremely subtle. Shivering is a strong stimulus for the release of adrenaline, epinephrine, into fat and the increase in fat oxidation and mobilization. And there are other subtle forms of movement that can greatly increase fat metabolism and fat loss. There was a group in England during the 1960s and 70s that discovered a pathway by which subtle forms of movement can greatly increase fat loss. This is the work of Rothwell and Stock. It's very famous in the thermogenesis literature. And I learned about this early on when I was an undergraduate. And I asked, how did they come across this? And here's how the story goes. They were aware that some people overeat and yet don't put on weight. Other people overeat even just a little bit, and they seem to accumulate extra